Hey everyone, super excited to be here. Yes, it's Jessie August, just like the month with an E on the end. You got it in the end. And yeah, really, really excited to give this introduction to OWASP. I think your position on how you feel about security and web app security is what the majority of engineers feel and developers. So I'm really hoping that I'm able to inspire you and make you feel a little bit more empowered to, yeah, go on this journey. So let's start. So yes, I'm Jessie. I'm part of the Coding Black Females team. I am a software engineer at CyberSafe, and I'm also the co-host of a tech podcast called Glowing in Tech. So just to go back to what you started with, 81% of developers have knowingly released vulnerable applications. I do not think this means that 81% of developers do not care about application security. I just believe that there is a barrier to entry with understanding secure development fundamentals. And so I'd like to give you a little bit of an introduction into what we can do to make our development more secure. And I also want to make the point too that in order for security to work well, it needs to prioritize the people using that technology. And so when security is working well, it should barely be noticeable. It should work for everybody, even my grandmother, who is not the most tech savvy user of some applications. If my application is secure by default, she shouldn't have to even notice that there's anything happening. So I think that's something that I'd really think is important when we're considering building secure web applications. And I'll start as well with a definition of cybersecurity. So it's the ongoing effort to protect individuals, organizations, and governments from digital attacks by protecting network systems and data from unauthorized use or harm. And then also to go on to and expand a little bit with web app security specifically, it's the idea that the application or web app that we're building should function as expected, even when it's under attack. So it sounds scary, it sounds like a lot of responsibility, but we need to think about how we're implementing security controls and engineering a web application in a way that will protect assets of those people at all costs. And so this is where OWASP comes in. It is an incredible resource and something that I hope you all go away and have a look at after this. And it's based on the foundation that open and collaborative knowledge is the way that we're going to solve this crisis that we have with web application security. And so essentially what it is, you were so close with getting all the letters, it's the Open Web Application Security Project. So it's a collective of engineers, many of who are contributing and giving their time to produce loads of free documentation, learning resources for all levels, and some really cool applications, which we'll get into as well. And then there's the OWASP Top 10. So this is globally recognized by developers as the first step towards more secure coding. And something that I'm really loving in the tech industry is I'm seeing an increasing amount of job adverts requesting some knowledge of the OWASP Top 10 and requesting knowledge of secure development fundamentals. And it is a great place to start for sure. So how do they figure out what happens in the top 10? They are very open about the calculations that go into figuring out what exactly is the top 10. But essentially, to summarize, it's a lot of research. And this list is updated at around a pulse of every 3 years so that it's keeping up to date with that threat landscape. And the key to the OWASP Top 10 is that it's providing you a list of actionable information which you can use to benchmark your code. So it's not that you're going to understand and remember all 10 of these at all times every time you're writing every single line of code. It's more that when you're pushing something to production, when you're shipping a new feature, you can refer to this list and check that you've thought through it. But again, we'll get a little bit more into these. So I'm not going to have time to go through all 10. Unfortunately, I have selected just a couple to give you a flavor of what some of them are. And I hope that you're able to kind of go away and think about them and also have a look at the others. But I'm going to start with the number 1, which is broken access control, because yeah, it's incredibly important. It's very frequent. It occurs very frequently in web applications. And I think there are some really quick fixes that we could all implement if we bear them in mind. So broken access control has more occurrences in applications than any other category. And what it is the scenario where an attacker can access, modify, delete, or perform actions outside of an application or system's intended permissions. Super broad. But if I give you an example, it's when a normal user is able to access admin-only features by changing the parameters in a URL. So I'm going to app.cybersafe.com, and under settings, you can see that in the URL, I've got my user ID, and that's how it's deciding what to show me. And a malicious attacker could modify that URL and change the parameter to be ID equals 1. And that's most likely the first user created, and also likely to be the admin with all the superpowers and be able to do things that they shouldn't be able to do. So what we need in order to prevent that is access control, which is enforcing a policy, meaning that a user cannot act outside of their intended permissions. This is based on the basic principle that an admin should be able to do a little bit more or a lot more than a user can. And again, so you can see that if we have the correct authentication in place, then it's required in order for the person to be able to make that change or view that information. And so the access control denies them access, even though they've changed the URL parameter. Whereas in the poor access control design, an unauthorized user is able to access the data because of that broken access control. And then all of the things that could happen, you can imagine, you could have unauthorized information disclosure, destruction of data, somebody performing actions that they should not be able to do. And some of the ways it can happen, because there's a lot, as with all of these, there's a lot of context to why a particular application is vulnerable in a particular way, but it can be down to the violation of the principle of least privilege. So when we're building things and when we're advocating for the user and we're truly thinking about how to keep them as safe as possible, we should have a deny by default principle. And what that is basically making sure that anything that has any access level that has particular capabilities is not available to anyone, and you are having to then modify and add that permission for that page. And then bypassing the access control checks by modifying the URL in that example can mean that somebody is able to use attack tools to modify API requests and start doing some really malicious things. So again, and the editing and viewing of someone else's account and their data, and then accessing APIs with missing access controls. So I might be trying to access an API that shouldn't have, but does, because we don't have deny by default, the post, put, and delete. And so we also have things that we can put in place, such as making sure that we've got good authentication to prevent a user from acting as a user without being logged in, or acting as an admin when being logged in as a user. And then there's also metadata manipulation. So people being able to tamper with JSON web tokens and cookies or hidden fields in order to abuse those JSON web token validation processes. So this can happen through cause misconfiguration and forced browsing. I don't want to go into these in too much detail, and I will provide more resources. I'm just very conscious of time. So please feel free to ask questions if you do want to know a little bit more about these. But essentially, it's just all the different ways or different things that a user could do if they're acting maliciously and they're able to utilize that broken access control vulnerability. So you might think, oh, it seems like it's not a very common occurrence or something that might not happen in real life, but we have an example from Facebook business pages, and somebody disclosed to Facebook that it was possible for a malicious user to use a request to assign admin permissions to themselves for any Facebook business page. So here's the sample request that they were able to use, a sample request of the request they were able to do in order to turn themselves into admins, essentially. And all they had to do was modify the URL and put role equals manager. You can imagine how catastrophic this could be if somebody had not reported this vulnerability and there have been other people that have been able to take advantage of this. They would essentially be able to act as an admin for any of the business pages on Facebook, of which there are many. So yeah, and it returned a response of true when the person did that, which is quite scary. So how do we prevent broken access control? We've touched on it a little bit already. Authentication, correctly identifying a user when they return to an application, super important. authorization, and this comes back to the deny by default. A user should not be able to perform an action, defining the actions that a user should and should not be able to perform once they have been authenticated, and making sure that those checks are in place with permission checking. So evaluating that user at a point in time when there's a request to perform an action. And then I'm going to move on to the next one, which is identification and authentication failures. So this is number 7. And this is what happens when functions related to a user's identity or session management are not secure. So attackers are able to exploit identification and authentication failures by compromising passwords, keys, session tokens, or exploiting other flaws, allowing them to assume others' identities. And session management is a really important part of web app development. It's just essentially the ability to keep track of a user after their very first request and assigning all of those requests to that user. So they have the pre-auth session, then once they authenticate, their session is being managed, and then you're viewing the access control they have and essentially assigning every request they make to that user and that session. So it starts when a user is authenticated, and it keeps the requests and transactions linked to that user. Attackers can use a range of techniques to exploit broken authentication, including brute force and credential stuffing, session hijacking, session fixation, cross-site request forgery, execution after redirect, and one-click attack. And we're going to have a look at what credential stuffing is. It's essentially using a list of compromised user credentials to breach into a system. This is a sophisticated attack because it uses bots for automation, and it's based on the assumption that we as humans, which we are quite prone to, we like those shortcuts. We need to be able to reuse usernames and passwords across multiple services. So statistics show that about 0.1% of breached credentials attempted on another service will result in a successful login. And again, this sounds like a very small number, but if you think about automation and the bots and the power that has just in order to iterate through users' compromised credentials across a variety of websites. And collection 1 to 5 made 22 billion username and password combinations openly available in plain text to the hacker community. So these sophisticated bots can simultaneously attempt several logins which appear to originate from different IP addresses. So that means they're overcoming security measures like banning IP addresses with too many failed logins. So how on earth can we expect to stand up against things like this when, if we compare credential stuffing to brute force hacking, brute force attacks guess credentials with no context. So that's just somebody using random strings and commonly used password patterns. And these only succeed if users choose simple and guessable passwords. So we can implement the kind of strength-based password creation, and that can eliminate a lot of the risk in terms of brute force hacking. But brute force attacks lack the context and data from previous breaches, and so their login success rate is much lower. So what can we do for credential stuffing? If we look at Deliveroo, we see that they've been hit with lots of, I love this article calling it mega breaches. It's essentially people being able to reuse those breached credentials. And because something like Deliveroo can be considered by a lot of people as a throwaway account, people aren't putting those extra steps in to make sure that they're changing their passwords on accounts like that. So the CEO of Deliveroo actually said that sadly, cyber criminals can rely on the fact that people reuse the same passwords, multiple online services, and use data breaches to gain access to other accounts on the web. We continue to roll out measures to combat fraudsters on Deliveroo. And it's important to note here that none of the company data or systems have ever been compromised. This is purely users having their accounts compromised due to credential stuffing. So that's a quick overview of the threat landscape, some of the things that can be threatening and things to consider when you're building a web application. But I really want to stress that it's not all doom and gloom. There are solutions to some of the things that I've shared, and I absolutely want you to feel like this is within your control to have a positive impact on your company security culture and on your own web applications as well. So for the credential stuffing, if we're making sure that we're using built-in session management and generating random session IDs with high entropy after login, then we know that we have the ability to make sure that people are not acting as users and able to compromise user accounts that way. And then also we should make sure that our session identifier is not anywhere available in the URL. It's securely stored. It's invalidated after logout, idle, and absolute timeouts. And that's just to make sure that nobody else can hijack a session and essentially pretend to be that user by getting their credentials for that session. And then another thing as well, I think making sure that we don't have unnecessary features enabled or installed. It can be really, really tempting to add lots of lovely new frameworks and utilize loads of libraries, but especially where we are keeping a lot of user data and we're being trusted with the user's information, I think it's important to build minimally and avoid unnecessary additions. And of course, this is on a sliding scale, right? And if you're building something that is purely a fun passion project, you're not storing loads of sensitive information, you can be a little bit more, I guess, adventurous with this. But I think it's important when you're thinking about building something that contains really highly sensitive information, something that you would not want to be compromised, like medical data, financial data, things that are highly personal and identifiable to the user, that you're advocating on their behalf by making sure that you're following that deny by default and building as minimally as possible in order to make sure that you've got the minimum amount of kind of vulnerabilities and exposed. And another quick tip, I think, is error handling reveals stack traces or other overly informative error messages to users. And I think this example is really helpful. We can see here that the user who is on the left trying to access this account, they've entered a password and the response, the error message is that the password is invalid, please try again. So if I'm an attacker, I know that this person has an account on this service and it's just a simple matter of me either credential stuffing or brute force attacking, and I can get in. Whereas this one from Google on the right, when I've incorrectly entered a password, it says that the username or password I entered is incorrect. And it's a subtle difference in the presentation and the language, but it makes a massive difference in terms of somebody who could be trying to gain access. So yeah, and then a couple of other things is considering, make sure you consider this security in your error message design and make sure you're not revealing too much information. And then also checking your production application is not in debug mode. I know we mentioned some easily made mistakes at the beginning. That's another one I see happen in people's side projects especially. I'm going to go into some more secure development hacks just because I'm conscious of time. And this is essentially a compilation of some resources that I think would be fantastic, especially as a JavaScript developer. So I will put all these links in the document too. So the first of them is the OWASP cheat sheet. So I know I've been talking about OWASP a lot. I do think that they have a fantastic collection of resources and they are free to use. And the OWASP cheat sheet is a fantastic example of that because it's essentially making sure that when you come across a concept or there's something that a particular vulnerability or threat that you want to look into, there's one sheet, a one pager on what it is, how to overcome it, and ways that you can test for it. So this is an example for input validation, which would be really helpful for figuring out how to make sure that you're not vulnerable to cross-site scripting. The next one is Threat Dragon. And I think this might be possibly the cutest mascot of all time for a tech app, for a web app. It's a web app that allows you to record possible threats and decide on their mitigations, as well as giving a visual indication of the threat model components and threat surfaces. So this is really, really helpful for when you're first getting into building an application or you've got a new feature you're trying to scope. You can essentially create a visual diagram that will show you a threat model for you when you're designing, creating the architectural design for that feature or application. And then the final one I want to show you was the OWASP Z attack proxy, ZAP. this is a really fun one, especially if you've not tested your own applications before. But it's a free web security tool that's actively maintained by a team of volunteers, and you can test your web application. It's like a free pen testing tool, so it can be really good to kind of automate the process of seeing where you may have some vulnerabilities. But it's not going to catch everything, right? Like you might not always be able to trust it 100% if you're using this. So I just want to come back to the point at the beginning of why you should care about web application security, why you should take the time to learn a little bit about the OWASP Top 10 and OWASP and web security in general. I think it will make you a more user-focused developer. When I think about the engineer I was before understanding web application security versus after, I now understand the importance of advocating for a user's needs and being that kind of first line of defense when it comes to somebody trusting you with their data and using your application. You need to be the one in the room that is advocating for them when somebody's proposing collecting more data, for example, and thinking about the ways that you can put up as many defenses as possible to stop an attacker from gaining access to that information. I also think it makes you catch vulnerabilities earlier. The more you're considering, especially with kind of threat modeling tools and including web application security principles in your design of technology that you're building, you will be able to catch those vulnerabilities earlier, which will save you a lot of time when rather than fixing things once they're in production already. And also, you'll build secure code by default. It can be really overwhelming at first, and there's a lot to consider. But I promise that once you've understood some of the foundational principles behind some of them, you'll begin to understand. And I believe it will become a lot less overwhelming, and you'll just start to understand and do this by default, which is an incredible feeling. And I believe that people who build secure web applications are incredible engineers. So yeah, I think that everybody should take the time and absolutely get involved and get interested and have a look at some of the ways that you can test and also have a go at like trying to hack your own applications. So I'm going to include all of these, the further reading and resources that I recommend in the document. And yeah, that's everything from me. Thank you so much.
That was a fantastic doc. Thank you so much, Jessie. And I'm so glad I got your name right towards the end. Phenomenal. I really appreciate that. We have some awesome questions. I'm sure everybody at home watching is clapping their hands as well. But I wanted to take a moment and answer a couple of these questions, or rather ask a couple of these questions to you who will answer them. Excuse me. The first question is OWASP actually run by a hive of wasps? Someone put that in there. I think the answer is false, but anyway, on a more serious note, there's been some updates to Chrome DevTools that now allow people to change headers at like after the fact. So when you load a website, you change a bunch of headers and so on, and then replay requests. You can do this now even with cores. I'm curious about the security implications of that, and if that presents like some type of attack vector or something.
There's definitely a lot of vulnerabilities in being able to manipulate cores. I don't know specifically about the Chrome DevTools though, because I feel like, yeah, I know that there's a lot in terms of being able to manipulate requests. I'm not sure about this one, but
That's
I'd
all
be
right.
happy to have a look.
I find it really interesting that Chrome. I'm sure the Chrome folks probably put a lot of thought into it as well. There's probably a blog post floating around somewhere about the rationale behind that. But I thought that was particularly interesting in the context of, messing around with things like that. I just wanted to shout out one thing from your talk that I absolutely appreciated, and I just wanted to personally thank you for it, which is you showed this thing where applications being kind of like pretending that they don't know things is a security feature. For example, like in GitHub, if I go to a private repo that I'm not supposed to know about, GitHub will just 404, similar to this user login thing that you showed. Instead of saying, that's the wrong password for this user, just pretending you don't even know the user. How that can be, while maybe a bit of a UX faux pas, more of a security feature. So I really appreciate that. Also, so there's a question around this Facebook thing that you shared, the huge security issue with Facebook pages or business pages. Because of this this URL parameter, role equals manager, that somebody changed and then got access to it. You mentioned practically deny by default is a great way to mitigate that. I'm curious what other way I've seen in the past, metadata like this being obfuscated by JSON web tokens, where unless the signature matches, you don't have any chance. I'm curious along those lines, practically how else those watching, the curious developers, would be able to mitigate against things like this.
Yeah, I think it should be handled differently. I don't think you should be able to manipulate, or I don't think you should be searching for a role from the URL. I think it should be something that is happening in the back end when you're as part of the session management. When you've authenticated a user, you should know what their role is. And then at the point of making a change, you should be validating that that user is who they say they are and that they have that permission, rather than being able to do it simply from the URL parameter. Like there are certain things that would be okay, right? Like, yeah, I don't know, like, yeah, what the users, yeah, I guess the normal things that you would modify in a URL, like the page that they're viewing and maybe the amount of results that you're displaying, and that is normal to put in the URL parameters. But I just don't think that anything related to privilege and permissions should be used as a validation, as a way to validate. So I don't know how they managed to happen to do that at Facebook.
Yeah, right. So as a practical, especially because their interviews are so hard. I've interviewed with Facebook multiple times, and it's all these like sophisticated questions, and then like people with the job do stuff. Anyway, that's not to say anyone's beyond mistakes. I'm sure that happens pretty often. Great.
Absolutely.
One more, and this is probably the last question before we transition to the break. I'm curious. A lot of people in the JavaScript ecosystem talk about secure session storage. Specifically, for things pertinent to this current user in this current context. So they'll talk about mechanisms like local storage, IndexedDB, cookies, etc. I've heard multiple debates where people will curse local storage as a mechanism because if somebody's able to guess the key, they get access. And like any script running on the page can access things. And I've heard people glorify cookies to the point where if they're HTTP only, no client side JavaScript has access to them and things like that. I'm curious if you have a take there, and I'm sure it's more nuanced than one is better than the other. But just generally, I'd love to hear your thoughts on that in a few sentences.
Yeah, I think it's a great question, and I do think I think my answer would be a bit of a grey one, because I think it completely depends on the type of application you're building, and if it is something that you feel, depending on the information that you're trying to keep and what you're holding about the user. Again, if it's like financial or medical data, then it has to be something that is a lot more secure than simply storing it locally, for sure. But then something, I guess, where you're not requiring authentication, where you're merely like keeping track of a session in order to personalize a website for them. I think in those cases, I think it makes like it doesn't need to be so rigid and so secure. But definitely, I think it depends on the type of data that you're then gatekeeping and you're trying to protect.
Awesome. That's a really great answer. Thank you so much for that. Hey, everybody, let's give it up one more time for Jessie August. Thank you so much, Jessie.